Every day, modern cities generate thousands of tons of municipal solid waste, and disposing of it remains a massive logistical crisis. This photograph shows the scale of an unmanaged sanitary landfill being scavenged by individuals. Dumping waste in these sites produces hazardous ground leachate and releases methane, a greenhouse gas far more potent than carbon dioxide. This image captures the thick black smoke rising from open burning. Traditional incineration attempts to reduce waste volume, but it causes severe air pollution, spreading toxic ash and volatile gases directly into surrounding communities. The K2 carbonization system offers a completely clean, highly efficient, and environmentally sustainable alternative to these toxic legacy methods. In this training, you will learn how to convert raw, mixed municipal waste into non-flammable charcoal in exactly 20 minutes, with zero harmful emissions. By mastering this system, your role shifts from managing a municipal hazard to generating a clean, profitable resource. Step 1 is preparing the incoming feedstock. Dump the raw, mixed solid waste into the main hopper and run it through the shredder until it reaches a uniform size. Next, we prepare the K2 enzyme binder. This specialized liquid solution is formulated entirely from natural marine fossils and inorganic materials. Looking at the bottom panels of this technical photo, you can see the liquid binder and the final coated crushed waste material inside the basket. Thoroughly mix the prepared binder solution with the shredded waste until it is completely saturated. The liquid binder envelops each waste particle, forming an impenetrable barrier. This creates a localized, oxygen-free state directly on the surface of the waste. Achieving this uniform oxygen-free coat is your most critical preventative measure. It stops the waste from catching fire and emitting toxic smoke when we expose it to high heat. Now, we initiate the machine's preheating sequence by engaging the diesel fuel burners. You must closely monitor the internal temperature gauges. Keep the burners running until the main combustion chamber achieves a baseline of 400 degrees Celsius. This initial diesel consumption is strictly temporary. The system is designed to automatically shut off the fuel supply once you hit that 400-degree baseline, which takes 10 minutes. Establishing this precise, high-heat, anaerobic environment allows the rapid thermal conversion of the waste to occur without any open combustion. With the machine preheated, begin feeding the binder-coated feedstock into the system for indirect heating. This diagram illustrates the carbonization plant's components. On the left, green biomass enters the hopper, feeding into the rotating drum. Inside, temperatures reach between 300 and 850 degrees Celsius. The extreme heat drives the chemical reaction without causing a fire. As the material moves through the cylinder, the solid waste balls are chemically altered into a lightweight, highly porous material. The total processing time is approximately 20 minutes. Check the extraction conveyor on the bottom right to verify the final product is emerging from the charcoal cooler. Completing this phase successfully extracts the hazardous elements from the raw waste, leaving you with a clean, stable product known as K2 new charcoal. While the charcoal is extracted, your attention must shift to the air pollution control system to manage the internal exhaust. This schematic maps the plant's air pollution control system. Any toxic gases evaporating from the feedstock do not escape. As indicated by the red arrow exiting the combustion furnace, they are routed upward into a secondary chamber to be safely burned off. The system operates on a thermal energy recycling loop. Hot gases are drawn back to the dryer via an absorption blower, drastically improving overall thermal efficiency. Next, the exhaust passes through the heat exchanger, an electrostatic precipitator, and a lime scrubber. Verify the exhaust parameters at the chimney, marked by the dark blue arrow. The filtered gas expelled from the stack must be at a safe 25 degrees Celsius. Rigorously monitoring this closed-loop filtration system guarantees zero toxic atmospheric emissions. This safety profile separates the K2 system from traditional polluting incinerators. The 20-minute operational cycle is now complete. You have successfully converted raw, mixed urban waste into stable charcoal without producing toxic smoke or leaving behind hazardous ground leachate. This process flowchart shows the profitable commercial applications for the newly created non-flammable charcoal. Notice the outputs on the right side, labeled building materials and soil enhancers for agriculture. Looking at the bottom row of the chart, you'll find the secondary economic benefits. The plant's excess heat loop can power a cloud generator for municipal electricity, and the clean process generates valuable CO2 carbon credits. Operating the K2 carbonization system successfully transforms a city's greatest liability into an economically robust, highly reliable, and sustainable asset.